So we're going to get into percentile and some other stuff like that later, but here we got mathematic. This is the backside of that sheet we talked about the empirical rule with. So when you hear empirical rule, you need to think three numbers. What are those three numbers?
100.
No.
98. I mean 68. 68.
68.
So what's first?
60.
68, then?
95.
And then?
99.7.
99.7, okay?
I'm not gonna
What are we looking at?
Ms. Wolski, can you go just make a copy of this first line? I cannot find another copy of it. Yeah. Alright, so the mathematic activity, this is what you got last Friday. Okay, so we are looking at the back side of it, right here. Yes, just one please, thank you. Alright, so empirical rule, what is it? What's the three numbers?
68.
68,
95.
95,
97. Like
99.7. What we said, or what we discovered when we did that applet yesterday, was that 68% of the data is what? Within 1 standard deviation of the mean. 95% of the data is within 2 standard deviations of the mean. And 99.7% of the data is within 3 standard deviations. Now, would all of that hold true for this distribution?
No, because it's not a bell curve.
It's not a bell curve. Remember, the empirical rule, the 68, the 95, the 99.7, only works with a,
Bell curve.
called a,
Bell curve.
Density
Call
curve.
a-
Density curve.
normal distribution. Okay, so remember, bell curve is just the shape, but it's called a normal distribution, or approximately normal is really what it is. Okay, so sketch the normal curve that approximates the distribution of waist circumference for women who are 8 months pregnant, label the mean, and values that are 1, 2, 3 standard deviations from the mean. So remember, you're going to have to practice this. You're just going to have to practice getting that normal distribution approximately right. You're not going to have to do it perfectly. But what's right here in the middle? The mean. What is the mean here? What is it? 44. Okay. Now, what was the trick that I showed you all yesterday to figure out where, not trick, but where it really is? How do we find where 1 standard deviation is?
Where it concaves in the concave.
So where it's changing that concavity, which is called a point of inflection. Michael, hold on to that because that's going to show up in Cal a lot.
I don't wanna. Stop, I can't.
Okay, so notice before there it's concave down, after that it's concave up. That's 1 standard deviation. So what is that value? 48, right? We increase by 1 standard deviation. Take that distance and replicate it. Repeat it.
So how do you know where? Oh, you just add 4.
You just keep adding 4. That's my standard deviation. Remember, there's roughly 3 standard deviations to each side. Okay, so what is this going to be over here?
40. 40.
40, then 36 and 32. There's my normal distribution. Notice this is my mean centered at 0. This is 1 standard deviation above the mean, 2 standard deviations above, 3 standard deviations above. So 1, 2, 3. And if we go below, what are we going to use? -1, -2, -3. Okay, so there's my standard deviations above and below me. Okay. And I know you missed yesterday, but so you definitely don't want to miss that.
Yeah.
You missed some important stuff
Yeah,
with the normal distribution. Okay, so that's it though. That's the normal curve. That's got the mean. It's got my standard deviations in there.
You lose your pick.
Okay. Huh? We started with the demonstrated understanding and just finished going over it. So we have, it's on the quantitative data stuff.
Okay.
Talk to me for a second after class. To
Can you
get
have
each
it
other.
that much?
It'll take me 2 minutes max.
That's 2 minutes. How long? is that?
60 seconds. All right. Number 1. So, what are your questions about drawing this normal distribution? Unless your name's Sanaya. She'll have to wait.
Okay. Would the median be in the same place as the mean?
Why would the median also be 44 here?
Because
It's normal. Symmetrical.
Not even,
Roughly.
but I would say, it's because it's symmetrical, not even just normal. So
Okay.
as long as it's symmetrical, the mean and median will be the same.
In this case, would the like IQR be similar to the standard deviations?
Well, remember, what percent of the data is within one standard deviation?
I forgot.
68.
68%. And what percent of your data is between the quartiles?
25. Wait, 50.
Between both
Oh,
quartiles?
both.
There's 3
50%.
quartiles, you gotta be more specific.
Yeah, I thought you meant just one quartile.
Cause you called median quartile too.
It is technically the second quartile in AP statistics.
It's,
Just talking about lower and upper quartiles, Q1 and Q3, okay? All right, so there it is. What am I looking for? So we're done on sketching it. Part B, waist circumference greater than 52 inches may indicate excess amniotic fluid. What percent of women who are 8 months pregnant may have excess fluid? So first off, I know I'm looking at 52, right? Boom. Which direction am I going to shake now?
That way.
Because we're worried about excess, right?
To the right.
So to the right, to the right. All right, so
Yeah, so 5%, because 100 minus 95.
what do y'all think?
Wait,
But-
isn't
That's
95%
only one
also the
side
stuff
of it,
down
so-
there?
So remember,
So 2.5%?
there we go. So 95% is from 2 below to 2 above. So there is 5% outside of that, but that's including here and here. So 5 divided by 2 is 2.5%. Okay? Now, I do want to show you one thing to make that a little bit easier if you're not as comfortable with how we're doing that tails. Because that's one way to think about it. What I have started doing, especially with my Algebra 2 classes, to make this easier is this. What percent of my data do I know is to the right of my mean? 50%, right? And then you'll set that 95, right?
Mhm.
But notice I'm only dealing with half of that 95. So that would be 47.5?
Yeah, it's a lot easier to divide by half.
I mean, that's up to you. I'm just saying 50 minus 47.5 is also 2.5. Because here's the thing, if you're comfy with that, I'm comfy with you doing it that way. But not everyone's comfy that way. But understanding, like, I don't want this 47.5, so you take your 50 and subtract 47.5, you're up to 2.5. Nice and easy.
Good.
We're going to also learn other ways that will always work, so you don't have to use the empirical rule. But the empirical rule is really easy when you're dealing with integer number of standard deviations. Okay? So what are your questions about that one? Does that make sense, how we got that 2.5%? Name line, I know y'all saw that last year, so does that
Peter,
feel a little
you need
comfy?
to check for amniotic fluid.
Alright, C. About what percent of women who are 8 months pregnant have a waist circumference between 36 and 40, so only here to here?
I heard it. I've been hearing it. Like 95 and then.
25%?
Wait, let me put.
47.5 minus.
Wait, okay,
Well, it'd
no,
just be
only-
that one minus
wait.
that one. You subtract them.
Wait, only,
What are you talking about?
Wait,
Oh wait, would it be 60? Wait,
50%.
95 minus 68 divided by 2?
So you can do it that way. So if you take 95 from here to here, and then you take out this 68, that leaves you with this region and this region, right? So 95 minus 68, but I don't want both of these regions, I only want one. What I would have done is, I would have said, hey, this right here, that's half of 95. And then this is what you were saying, Jaden, right here, that's 34% or half of 68, so I take away half of that 68. Notice that's exactly equivalent to this. Those are the same things. But 47.5 minus 34 is 13.5. So it is figuring out how to play with those numbers to use our empirical rule to find those percentages. Okay? All right. With the amount of time that we have today,
We do that.
I'm trying to think.
Michelle, take
No,
it.
I'm gonna need you to do the skew the script questions, practicing with this on your own tonight. You can ask questions tomorrow. So that's these questions right here. Did I take this from somebody? Okay, so I need you to try this. The first 4 there are just normal distributions, very similar to what we've been doing. I mean, just like we've been doing. The back side, though, is where you have a couple of word problems applying these ideas. Now, we have not talked about percentiles yet, have we? I don't think so.
No, you're
Yeah,
not.
okay.
99%.
Yeah, so that's probably something you've seen before, huh?
Like the 25th,
He was just calling you smart.
Yeah, 99th percentile is good.
So here's a stack of papers that are the rest of this unit. I put them in order of how we're going to do them.
Oh, shit. Oh,
Okay.
this is for me.
Yes, that is for you, Sanaya.
I'm thinking this is like a piece of something, I don't know, I should have left.
Okay?
It's a lot of crap.
Oh my gosh.
And those ones, is those ones,
Trees. The end got from my feet were working English.
Remember
they fell.
the whole house died?
That's where those were.
Oh.
Found those.
Why is the sheet like?
Okay, the rest of the unit. Alright, so I need y'all to look at, you can just put it in your 3 reminder and not.
I actually do both.
Alright, so what we're about to focus on is what's called a cumulative relative frequency graph and percentile. You'll need this percentile for one of the questions tonight, okay? And we're still working with interpreting measures of center and variability in context, and we're using percentiles right now. Okay, so describe this distribution. When I look at this distribution, we're just going to talk through it because of time. How would you describe this distribution?
It's pretty even. I think it's symmetrical.
Okay, so roughly symmetrical, approximately symmetrical. Do you notice it's not exactly symmetrical because these two right here, but it is approximately symmetrical. Cool, I'm good with that. Jaden, you said bimodal?
Yeah.
Yeah, maybe. That's a little funky. It kind of evenly dips down and back up, so I could accept bimodal. So bimodal, approximately symmetrical.
The minimum is 56 and maximum 78.
Back in a second. Y'all have like completely. You're right, but like you've completely skipped one of the most important parts of analyzing this distribution.
I mean, the mean 68.
Context.
Thank you. Oh my gosh.
No one
right?
cares about context.
No, everything matters with context. Like that is all that matters. Okay, so you could start with mean. I would probably start there. The mean what? Height of 20 AP stat students is
68 inches.
it's not 68.
67.4.
You could report 67.45 as the mean, or you can talk about the median as 67.5. Either one is fine. I will point out this mean and median actually does tell me that this is approximately symmetrical. How do I know?
They're the same.
They're basically the same, right? So it's so the mean of the heights of 20 AP stat students is 67.45 with a standard deviation height of 4.807 inches, which we need inches there. The distribution is approximately symmetrical and maybe bimodal. There appear to be, how many outliers?
2.
I would say probably 2 outliers, but notice I say appear to be because have I calculated if they are or not?
No, they're only potential.
They're only potential at this point, right? So that's analyzing it. Now, bless you.
Thank you. He said last.
So Ariana is 65 inches tall. This is what I need to focus on. So describe the context, the distribution. If you want to do that and we can talk about it tomorrow, go for it. We talked it through, but if you want to write it yourself, I encourage you to do that. Ariana though, 65 inches tall. That means she's right here. What percent of the heights are less than or equal to 65 inches? What percent of the heights are less than or equal to 65 inches?
Like a quarter. Like 5%.
To 25%?
Something like that. It's just 25%.
Wait, how'd you get that?
5 divided, like counted? 5.
So yeah, like right here, it's 65 or less, right? So how many data points? 5 out of 20
24.
is 0.25, or 25% are at that height or less. So we should be thinking quartiles for sure, right?
Well, I mean, it literally says Q1 right there.
So 25%. Now, actually, do notice Q1 is 65.5, which throws everything off a little bit.
Yeah, but you don't see anything in between that little.
Well, so here's something to actually notice then. So. Yeah. So here's actually something to notice. If Q1 is 65.5, that means Ariana is not actually in this data set. That's 65.5 inches. So Ariana is actually shorter than that value.
Ariana, what are you doing?
Okay? So Ariana is not actually in that data set. If the Q1 is 65. So we would actually have to say 4 out of 20, 20%. Now,
Well,
what is your height? What percent of the heights are less than or equal to your height? So someone give me a height. That they are
5'6".
You're 5'6". Okay, so 66 inches. Okay, so if we're going with Michael, who is 66 inches tall,
I don't trust that.
then
You don't trust
what percent of these students are at or below his height?
A few.
Like 8 out of 20.
So 8 out of 20 are at or below, so that's what percent?
40.
We good with that?
40%.
40%? So 40% of people are at or below Michael's height. So do you want to know what his percentile is? 40th percentile.
Let me see what mine is.
So, okay, so Serena, how tall are you?
5'3".
5'3", so
5'4", I don't know.
63 inches.
Oh, don't give yourself an inch now.
Well,
How tall I am.
if you're 64 inches, exactly what we just said of 20%, right? Because 4 or less. If it's 63 inches, right here, you only have 3 people shorter, so you would have 15% at or below your height. So what percentile would that be?
15.
15 percentile.
Ain't no way.
So, what's a percentile then?
Just how many people.
How many people are better than in a room
Yeah.
of 100 people?
It's not how many, that's for sure.
What percent
Okay.
of people?
So it's the percent
That's like what they normally compare it to.
of, but it's again, not how many. It's what?
Proportion.
A percent or a proportion. So it's a percent of, and let's put it in statistical terms, not people, but
Individuals.
individuals, because it could be people or not. So percent of individuals at, notice how I keep saying at, right? It is at something or below. Okay? So it's the percent of individuals at or below that value. So if on your ACT you saw that you were in the 70th percentile on the math portion, what does that mean?
You're above 70%, or at or below 70% of people taking the test.
And so be careful, right? Because it's definitely not that you're above 70%, right? It's the percent that are at or below your score. Okay, that's why we always have 99th percentiles as like the highest really, which is goofy. But the way we would report that, by the way, is not, and be careful about this because this shows up on the AP exam all the time. We never say in the 15th percentile, we say at the 15th percentile. Michael was at the, what percentile? 40th
You don't have to
percentile.
remind.
Well, at least not 15.
Well, now, I do want to point this out though, actually, so I want you to think about this. You're still within 1 standard deviation of the mean.
That doesn't help.
You're well within what is typical.
Oh, the stat is not
Can you
representative
explain
of the
what the
public
shirts
school
now?
population.
No,
So.
Later, not
I got a question.
Oh.
Go for it.
So you said the 99th percentile is the max. Why? Why can't it be 100? Like, what's
Because
the
there's
best?
technically always someone who has higher unless you are the person.
Yeah, so like,
It's
what
dumb.
what if you are the person? Like, what if I
Yeah.
get a
What if
perfect
you are the
score and I'm
person?
the only one who gets perfect score? That ain't gonna happen. Let's imagine.
I mean, there are people who have actually not missed a single question on the ACT.
That is
They still only ever report it. No, okay, so let me clarify. The back in the day, so this is not the way the AP exam does it, but back in the day, percentile was only interpreted as what scored less than yours. So then it could only be the 99th percentile, because 99% are less, you can't have 100% less than you. But the AP exam does it at or below.
So you
So it can be either way, and so the ACT does it the other way of what's below. I do know that.
So could you be the 100th percentile?
No, because you can't be better than 100% of people, because then you'd be one of those people.
You can be
Yeah.
better than yourself.
Alright, so
Yeah, maybe you have to be better than yourself.
percentile is the percent at or below. Do this for me just to save a few minutes tomorrow. Find the frequencies and the relative frequencies. Don't worry about the cumulative, just for lack of confusion. Just find your frequency of the heights in each of these. We'll talk about it
Can I
tomorrow.
tell you something funny I saw, like, short last week? So it's scrolling on YouTube shorts.
Yeah,
Yeah,
YouTube
it's
shorts.
not
That's
the
the first
YouTube
one.
shorts.
No. So it was about some like, it was about some vegan lady.
Not the YouTube shorts.
No. It was about some vegan lady, right? And she was so proud. She's like, guys, this is why we can homeschool our kids learn. This is just proof that homeschooling works. And we should do it. Well, you know, my sister or my daughter, we like my took an IQ test recently.
Like, not even 80 bio.
Oh,
This is my worst class. Mine's an 80
Or top 7
Right.
in the club.
Well, I have
And it was an IQ test.
That's so uncomfortable.
And she got like a 70 or 80. And then it was like,
Some of you don't know statistics.
the IQ test literally said, in a room out of 1,000 people, you'd be smarter than
No
them.
way.
And I was like, that's crazy, because the woman didn't understand that either. The mom didn't understand that either. Which is how you know it's like a parent thing.
You know what?
versus daughter thing.
My mom has